You are standing on a strip of volcanic rock in the middle of the Pacific Ocean. The nearest inhabited island is more than 1,900 kilometers behind you. The nearest continent is over 3,700 kilometers ahead. There is no forest here. There is grass and wind and stone, and there are statues, nearly 1,000 of them carved from compressed volcanic ash. The largest one ever raised stands about 10 meters tall and weighs more than 80 tons. They face inland. Not one of them looks out to sea. For most of the last few decades, you have been told what happened on this island. The people who carved these statues cut down every tree they had. They ran out of food. They turned on each other. They collapsed. A society that destroyed itself alone in the middle of the ocean. Recently, several teams of researchers went back to the physical evidence, satellite imaging, ancient bone, complete genetic codes recovered from the dead. The story stopped matching the data, and what has replaced it raises a question nobody has fully answered. Start with the standard account, because for a long time it was the best explanation anyone had, and it was built by serious people working with the evidence they could get. Polynesian voyagers reached the island roughly 8 centuries ago. What they found was not the bare landscape you are looking at now. Pollen preserved in lake sediment shows the island was covered in palm forest. Estimates drawn from the casts that tree roots left behind in the soil put the number somewhere between 15 and 20 million trees. Within a few centuries, they were gone. The explanation that followed was straightforward. The islanders cleared trees for gardens and for firewood. They cut more to move their statues. Competition between clans pushed the statue building to an extreme, and more trees came down. The population grew past what the land could feed, perhaps to 15,000 people or more. Then the food ran out. There was warfare. There was, in some tellings, cannibalism. By the time the first European ship arrived, only a few thousand people were left on an island of bare grass, surrounded by monuments they no longer had the means to build. The geographer Jared Diamond gave that account its widest audience, presenting the island as the clearest case in the human record of a society consuming the one thing it could not replace. The pattern acquired a name: ecocide, a society that ends itself by exhausting its own environment. It is a powerful account. It is also, at its center, in serious trouble, because the entire structure rests on a single number: the peak population. Without a large population, there is nothing to fall, and that number was never measured. It was inferred almost entirely from an estimate of how much of the island had been under cultivation. Recently, a team went back and measured that. The earlier surveys used satellite images that could not cleanly separate cultivated ground from natural rock. They put the cultivated area somewhere between 4 and 21 square kilometers. The new survey used a band of the light spectrum that responds to moisture and mineral content in soil, which makes worked ground stand out from bare stone. It put the cultivated area at 3/4 of 1 square kilometer, 5 to 20 times lower. On an island of 164 square kilometers, the food-producing land was not a tenth of the surface. It was under 1%. Run that through the same models used to estimate how many people the island could feed, and the answer comes back at roughly 3,000. Add fishing and everything else the sea provided, and the ceiling rises to about 3,900 people. Give or take 800. Which is almost exactly what the first European visitors reported seeing. There is no missing population. There is nothing that fell. But a number on its own proves nothing. To understand why this reanalysis carries the weight it does, you have to go back further, to a man digging in the sand on the island's north coast, and to what he found there that he was not looking for. His name is Terry Hunt. He is an archaeologist now at the University of Arizona, and he went to a beach called Anakina because the island's own oral history says that is where the first canoes landed. He was there to answer a narrow question. When did people actually arrive? The tool for that is carbon dating, which reads the slow, steady decay of carbon inside anything that was once alive and converts it into an age. The answer came back later than expected, not around 800 years after the Common Era, as had been widely assumed, but closer to 1200. That correction sounds small. It is not. It removes 4 centuries from the island's human history. Everything, the settlement, the quarrying, the raising of nearly 1,000 statues, the loss of an entire forest, now has to fit inside about 500 years. And in those same sand layers there was something else. Rat bone. An enormous quantity of it. The Polynesian rat, which travels with human voyagers across the Pacific, sometimes as food, sometimes as a stowaway. Alongside the bone were palm seed shells with the gnaw marks still on them. Hunt proposed something most of his colleagues did not want to hear, that the rats were not a footnote to the deforestation, that they were central to it. The reaction was fierce, and it has not stopped. 2 soil scientists working on the island, Andreas Meth and Hans Rudolf Bork, argued that the rats played a negligible role and pointed to seeds recovered from charcoal deposits that carried no gnaw marks at all. The archaeologists John Flenley and Paul Bond, who had done foundational work on the island's pollen record, argued the same. So did Diamond. They noted that forests in continental Chile had survived rodents perfectly well. It became one of the most contested arguments in environmental archaeology, and it is still running. Hunt and his longtime collaborator Carl Lipo at Binghamton University published a detailed point-by-point response only recently. The burnt seeds, they argued, were burnt, which makes them unattractive to a rodent. Gnaw marks are hard to identify on the seed fragments archaeologists usually recover, and the Chilean comparison fails because those rodents were native and those forests had evolved alongside them. So, hold the question open for a moment. If the population never grew large enough to crash, and if the forest may have been lost for reasons that were only partly human, then what actually happened to the people who lived here? The answer came from a field that had not been part of the argument at all. Start with the forest, because the mechanism matters. The palm that covered this island produced relatively few seeds, and each one was large and rich in nutrients. On a landmass with no native land mammals, that reproductive strategy carried no risk. There was nothing there that ate seeds. Then, in a single generation, there was. Ecological modeling of that arrival produces numbers that are difficult to absorb. A single breeding pair of rats landing on an island with abundant food and no predators could reach a population of 11.2 million in under 50 years. At that density, the models show seed predation running as high as 95%. That figure is what matters. A forest does not need to be cut down to disappear. It only needs to stop replacing itself. The adult palms stood for decades. They simply had no successors. Every year the canopy thinned a little, and every year almost nothing came up underneath it. There is a further piece of evidence here. In the Anakina deposits, rat remains do not increase over time. They fall by more than 90%. That runs directly against the older idea that islanders turned to rats as a last resort once other food was gone. The rats boomed early, stripped the island, and then declined as their own food supply gave out. And the pattern repeats elsewhere. On Pacific islands that rats never reached, native palms survived centuries of human occupation. On islands where rats arrived, the palms went, sometimes before people had cleared much of anything. None of this removes human responsibility. People cleared land near the coast. People used fire. The two effects compounded, and the researchers making this case say so explicitly. What changes is the shape of the story. Not a society knowingly consuming its own foundation, but a slow, largely invisible ecological process that nobody on the island had the means to see, let alone reverse. Now, look at what those people did next, because the old account left this out entirely. The soil on this island is volcanic and agriculturally close to hopeless. It is short of nitrogen, phosphorus, and potassium, the three things a crop needs most. So the islanders broke rock. They fractured stone by hand and worked the fragments into the ground, which exposes fresh mineral surfaces that weather and release nutrients. The same broken rock holds moisture in the soil, buffers the temperature swings, and shelters young plants from a wind that carries salt across the entire island. The technique has a name: rock gardening. Modern agriculture does the same thing with machinery. These people did it with their hands, on the most isolated inhabited land on the planet. And they grew sweet potatoes in it, along with dryland taro and yams. That is not the behavior of a society collapsing. That is soil engineering. So where does this leave the field? Broadly in three camps. The first still defends some version of the original account. The forest was destroyed by people. The consequences were severe, and the archaeological record shows real disruption. The second argues there was no demographic collapse at all before Europeans arrived. Robert DiNapoli, working with Enrico Crema, Lipo, Timothy Reith, and Hunt, took the island's carbon dates, which act as a rough proxy for how many people were alive and burning things at any given time, and fitted formal statistical models to them. What came out was not a rise and a crash. It was a rise, and then a long plateau. The third camp is the most interesting, and the least reported. The paleoecologist Valenti Rull, working in Barcelona, went back to the sediment cores themselves. His conclusion is that the deforestation was neither sudden nor island-wide. It happened at different times, in different places, at different rates. The appearance of a single abrupt event was largely produced by a gap in the sediment record several thousand years long, which had erased the gradual transition. And droughts, independent of anything people did, played a part. Not one cause, several interacting over centuries, which brings up the obvious objection. If the low population estimate is doing this much work, how solid is it? Contested is the honest answer. Christopher Stevenson at Virginia Commonwealth University co-authored the earlier and much higher estimates, and he does not accept the new one. His argument is methodological. The satellite model was trained on data gathered near the coast, and he says it misses the gardens that sit on the middle slopes of the island's largest volcano. Sarah Sherwood and Joanne Van Tilburg have pointed out that the study measures one cultivation method and leaves out the others. But Thane Laidfost at the University of Auckland, whose earlier work produced the higher figure the collapse model relied on, has accepted the new data and states plainly that no pre-colonial ecocide occurred and that the population did not collapse. The overall conclusion is agreed. The exact ceiling is not. And then there are the statues, which turn out to matter more than anyone expected. Lipo and Hunt measured 962 of them, paying particular attention to the 62 abandoned along the island's ancient roads. Those road statues share features the finished ones do not. A wide, D-shaped base, a forward lean of between 6 and 15 degrees. Those features make no sense for anything dragged horizontally on timber. They make perfect sense for something rocked upright, from side to side, walking forward under its own weight. The roads support it too. They are about 4.5 meters wide, and they are not flat. They curve inward across their width, which is exactly what you would build to keep a heavy, top-heavy object from tipping sideways as it rocks. They built a replica, correctly proportioned, weighing 4.35 tons. 18 people moved it 100 meters in 40 minutes, using rope, on foot. Just over half of all known statues sit within 2 kilometers of the quarry, which is consistent with a transport method where a certain number fall, break, and are left where they land. The island's own oral tradition had said this for centuries, that the statues walked. Outside researchers had recorded it and set it aside as legend. Follow that through. If a modest team can move a multi-ton statue with rope and no timber at all, then the monuments do not require an enormous labor force, and they do not require felling a forest to serve as rollers. One of the load-bearing assumptions of the collapse account is simply gone, which leaves the last question. If the population never crashed before contact, is there a way to check that directly, rather than by inference? There is, and it is where this ends. A team led by Victor Moreno-Mayar in Copenhagen, with Barbara Sousa da Mota and Anna Sapfo Malaspinas in Lausanne, recovered and sequenced the complete genetic code of 15 ancient Rapa Nui individuals whose remains are held in a museum collection in Paris. They were looking for something specific. When a population falls sharply, it leaves a mark in the genome. Diversity narrows. Long identical stretches of inherited material appear where they should not. That signature persists for centuries afterward. It is one of the most reliable records a catastrophe can leave. They reconstructed the island's population size through time. They ran extensive simulations, and they found no such signature. The severe crash the collapse account requires, in the century before Europeans arrived, is rejected by the genetic evidence. What the genomes show instead is a small population growing slowly and steadily. Then they found something they were not looking for. About 10% of the ancestry in those ancient individuals is Native American, and by measuring the length of the inherited segments, which shorten in a predictable way with every generation, they could date the contact that produced them. It falls within roughly 2 centuries of the island's settlement, well before any European ship reached the Pacific. So the island at the end of the world, whose isolation was the entire premise of the story, was not isolated. Someone crossed 3,700 kilometers of open ocean and came back, or was brought back, and the collapse did happen. It simply happened later, and it did not come from within. Just over a century and a half ago, slave ships arrived. They took roughly 1,400 people, close to half of everyone alive on the island, to work in guano mines on the South American coast. Most died within months. International pressure eventually forced a repatriation, and the handful who survived the voyage home carried smallpox with them. Within about 15 years, 111 Rapa Nui remained alive. Among the dead were the people who could read the island's written script. That is why nobody can read it now. It is one of a very small number of writing systems invented independently in human history, and the knowledge of it was destroyed inside a single generation. That is the collapse. It is documented. It is not in dispute. And for a long time, it was not the story anyone told. None of this means the island has nothing to teach. The forest is genuinely gone. People genuinely contributed to that. An ecosystem that took a very long time to establish was altered permanently within a few human lifetimes, and the causes were tangled enough that nobody living through it could have identified them in time. But notice what actually happened to the older account. It was not overturned by one dramatic finding. It was undermined by 4 separate lines of evidence with no connection to each other. The satellite survey knew nothing about the genomes. The rat bones knew nothing about statue physics. Each was answering its own narrow question, and they arrived at the same place. That convergence is the strongest thing science produces. It is also the slowest and the least satisfying, and it almost never makes it into the version of a story that people remember. The older account lasted because it was useful. It was a parable about limits, and the world had reason to want one. The question worth sitting with is not really about an island in the Pacific. It is about how much of what you are certain of is held up by evidence, and how much of it is held up by how badly the lesson is needed. That is a much harder thing to measure, and nobody has found a way to date it.